All right, in this lesson, we are going to talk about the different forms of quadratic equations. And so a quick review of vertex form from last class is when you have this form, you can see the transformations. And so you can see that this function has been moved right h up k, which means our vertex is going to be at hk. It moves from 0, 0 to hk. So take the opposite of what you see with x, and then take what's outside the parentheses to be your y. Okay, the axis of symmetry is always x equals, and it's always equal to the x coordinate. It's the line that goes right through the vertex, the vertical line that goes through the vertex. So this is hk. This would be the axis of symmetry, which would be x equals h. Okay, the direction of opening is determined by the a value. If it's negative, that means there was a reflection. And so if there's a reflection across the x-axis, that means it's opening down. Okay, if a is positive, there is no reflection, so it's still going to open up. So a cheesy way to remember that is positive is happy. So positive should be smiling, whereas negative will be frowning. It's sad, it's negative. Okay, so if you want to think of a happy parabola and a sad parabola. Okay, and then for the width, the greater the a value, the more vertically stretched it is. So if a is bigger than 1, which for the parent function x squared, it's 1. So if it's bigger than 1, it's going to be narrower. It's going to be taller. Okay, and then if it's between 0 and 1, and we're just thinking of the value, we're not thinking of positive or negative in this case. Okay, so if the absolute value is less than 1, I'm going to take that off since it will obviously be positive. So like 1/2, 1/3, it's going to be wider because it's vertically compressed. Okay, and so looking at some examples, I can see that the vertex is at -5, +20, taking the opposite of what's with x. And so that means the axis of symmetry will be at x equals -5, just taking the x coordinate. The direction of opening will be down because of this a value being negative. So it's going to open down. And then because the absolute value of a is 4, that means it's going to be stretched vertically, and so it's going to be narrower. Okay, for this next one, the a value is 1. So if you don't see a number out front, that means it was 1. And so looking at the vertex, we are right 3, down 6. And so 3, 6. Axis of symmetry, x equals 3. Direction of opening will still be up because a is positive. And then because a equals 1, it's the same as the parent function. So it's neither wider nor narrower. Okay, and for this next one, I hope you're noticing that it's not in the same form as the rest. Okay, we had parentheses, we had a square, we didn't have an x term. Okay, this is standard form. And when you have standard form, you don't get any of this information for free, other than the a value. You know a is going to be the same a value, and so we know it's opening up. We know it's going to be the same width as the parent function, but we don't know the vertex. You do not get the vertex for free from standard form, which means you don't get the axis of symmetry. Okay, and so why is example 3 more difficult to find the key attributes? Because it's in standard form. Okay, and so here when we have standard form, we have A, B, and C, which is not HK. That's not our vertex. Okay, and so we can use A, B, and C to find the axis of symmetry using the equation x equals negative b, or opposite of b, over 2a. Okay, and so once you have that value, you can plug the x value back in to find your y. Okay, so that will be your h, this will be your, this will be your k, this will be your h. Okay, so oftentimes I'll say h equals negative b over 2a. And then the a value is going to be the same a value regardless of which form we have. Okay, so looking at example 4, we are going to convert this standard form equation to vertex form. Okay, and so first I identify a is negative 3, b is negative 12, and c is negative 11. We don't need c for this, but just so you know what you're looking at here. Okay, and so to find h, we need to take opposite of b divided by 2a. So opposite of b would be positive 12, since he's currently negative 12. 2 times a would be 2 times negative 3, this negative 3. Okay, so that gives me 12 over negative 6, which simplifies to negative 2. Okay, and so now that I have the h value, that's my axis of symmetry. X equals negative 2, and that's the x coordinate of the vertex. And so in vertex form, our a value is going to be the same, so we're taking the same a value, and then what goes inside the parentheses is the opposite. And so we have a negative 2, so we're going to have a plus 2 inside the parentheses. And so now we just need to find the k value, right? And so to find k, you take your original equation, negative 3x squared minus 12x minus 11, and we're going to plug in the negative 2 we just found. Okay, so write down your formula without the x. Negative 3x squared minus 12x minus 11. That will save you from making mistakes. Okay, and so I've just written down this formula, and I replaced both x's with parentheses. In those parentheses goes the negative 2. You have to replace both. Okay, and so now PEMDAS still applies. We have to do the square before we multiply. Parentheses, exponents, then multiplication. And so negative 2 squared is positive 4. Negative 12 times negative 2 would be positive 24. Minus 11. Okay, and so that gives me negative 12 when I multiply, plus 24 minus 11. I recommend always simplifying to these three numbers right here, because if you've done everything right, this first number should be half of the second, and they should be opposite signs. That's only true if you have the correct axis of symmetry. Okay, so if this is the correct axis of symmetry and you've number crunched correct, this should be half of the second number, and they should be opposite signs. That'll help you find any mistakes. Okay, negative 12 plus 24 is 12. Minus 11 gives me 1. Okay, and so now that we have our k value, we know that the y value of the vertex is 1. And we would have a plus 1 outside. Okay, the a value, we didn't need to find the vertex to know the direction of opening. The direction of opening will be down because a is negative 3, which is less than 0. And it's going to be narrower because the absolute value of a is 3, which is bigger than 1. It's going to be vertically stretched, even though it's opening down. Okay, I'm going to skip example 5. It's similar, but even easier, and talk about root form. Okay, and so from vertex form, we get the vertex for free. From standard form, we have to work a little bit, but we can still get the vertex. from root form, we get the roots for free. And so this R1 and R2, those are your roots, okay? And roots are the same thing as x-intercepts. They're also called zeros. They're also called solutions. So we have 4 names referring to the roots, okay? And so if you're picturing the graph, it would be where it crosses the x-axis, okay? And those have 4 names. And so an abbreviation we talk about in Algebra 1 is ROCs, roots, zeros, x-intercepts, solutions. Okay, ROCs. They all refer to the x-intercepts. Okay, and so there is one difference between root form and factored form. For factored form, when we were doing our factoring lesson, you could have like a 3x plus 1 and a 5x minus 1 as your 2 factors. Whereas in root form, you would not have any coefficients. You would write these in terms of fractions rather than having a coefficient in front of your x. Okay, and so that's just a subtle difference. They're not necessarily integers when you're writing root form. They have to be integers when you're writing factored form. Okay, and so let's skip to the last example here. Okay, it says write the equation of a quadratic function whose roots are -4 and -2 and passes through this random point here. Okay, and so we're going to write it in all the forms: vertex form, standard form, and root form. And so which one you start with depends on what you're given. If you're given the vertex, you're going to start with vertex form. If you're given the roots, you're going to start with root form. And so because we're given the roots, we're going to start with root form. Okay, and so it's going to be a times x minus the first root, x minus the second root. And it doesn't matter which order you go in. And so here's my roots, R1, R2. And notice the minus signs in the formula. Whenever you see minus signs, it's going to be opposite. Okay, and so in root form, I don't know a, but I know one of my roots is -4. So you're going to see an x plus 4, minus negative. And then same with the 2. You're going to see an x plus 2. It's going to be the opposite. Okay, and so if you want to make note of that, opposite, opposite. Okay, and so now we just need our a value, and that's what this random point is. It gives us an x and a y that we can plug in for x and y. And so it says x is -5. So both of these x's are -5, and y is -9. Okay, and so when I substitute those into my equation, the only unknown variable is a, and we can solve for it. Okay, and so we just need to simplify some things. -5 plus 4 is -1. -5 plus 2 is -3. -1 times -3 is +3. And I'm going to write that in front of the a, just so it's easier to see what I need to do to solve. I need to divide both sides by 3 because it's being multiplied. So that means a equals -9 divided by 3, which is -3. Okay, and so now my completed root form is going to be y equals, we're going to put the -3 in. Let me write it up here. Y equals -3, and then we still have the x plus 4, x plus 2. Okay, and so that is root form. Okay, and so from root form, we are going to convert it to standard form by just FOILing the whole thing out. Okay, and so the first thing I'm gonna do is FOIL this. And so we do first, which is x times x, which gives me x squared. Outside gives me 2x. Inside gives me 4x. And then the last would give me 8. Okay, combine these like terms, you get x squared plus 6x plus 8. Put it back in parentheses because we still need to distribute the -3, and it gets distributed to all 3 terms. Don't just put that a value in front of the x squared. It gets distributed. That's a common mistake I see. So now we have -3 times 6, which would be -18x. -3 times 8 would give me a -24. Okay, and so this is my standard form. Okay, and so I can see A is -3, B is -18, and C is -24. Okay, and so standard form has no parentheses. It's just all multiplied out. Okay, root form has those 2 sets of parentheses. And now we just need to get vertex form. Okay, and so to get vertex form, we're going to do what we did in that previous example. We know A is the same A, so still -3. H is -b over 2a using the formula from above. This formula. And so -b or opposite of b would be +18, looking at this value here, +18. Over 2 times a would give me 18 over -6, which is -3. Okay, so I know a is -3. I know H is -3, and so we can start our vertex form, the A value, and then because H is -3, we're going to see a +3 inside the parentheses. So now we just need to find K by plugging this -3 in, and you can either use standard form or you can use root form. It's going to give you the same answer in the end. I like using root form better just because I don't have to square anything. And so in root form, I have a +4 and a +2. And then this -3 goes in for both those x's. I'm just taking this formula and replacing both x's with -3. Okay, and so now when we simplify, -3 plus 4 is +1. -3 plus 2 is -1, which gives us -3 times -1, which is +3. So our K is +3. Okay, and then just to show you that you would get +3 if you use standard form as well, I'll show that right here. -3x squared minus 18x minus 24. And you'd still fill in the -3 for both x's. Square first, you get +9. -18 times -3 is +54. -3 times 9 is -27. And notice, -27 is half of 54 and they're opposite signs. Okay, and so that would leave me with a +27 minus 24, which is 3. And so you're going to get the same answer regardless of whether you plug it into standard form or root form. I think root form just keeps the numbers smaller when you don't have a calculator.